Hey YouTube, I wanted to take this time to do a video on how to solder and set up your KISS flight controller. It's fairly new and I'm really excited that I was able to get my hands on it when it first came out and buy it before it sold out. I just haven't gotten the chance to set it up yet as I've been waiting for this video. I was also waiting for some 30 amp ESCs from DYS, the new XMs, to put on my alien frame with my higher 2700 kV motors. And so I've been waiting till I got all those parts in together to set up the new KISS flight controller, because from what I've read, I have a feeling that I'm not going to ever switch back. So that's why I wanted to make sure that I just did everything up all at the same time. But let's get started on how to set this up. Not everybody's going to be using the same thing, but I'm going to do it for what I'm using. Now I'm using the X4R Sbus FreeSky receiver, so I won't be using every single PWM port on here, and I'm not going to be connecting smart port on either, as I will be using a battery buzzer to monitor my voltage. Excuse me if I sound like crap, I'm getting over a cold. But first off, we need to know what the pins do, and fortunately flyduino.net provides us with a great pinout diagram of all of their KISS flight controller, and so it tells us where we need to put things. Now the VIN minus and plus right here, if you can see that, is the battery input for the positive and the ground. This flight controller has a built-in BEC with it on the backside, so we don't have to worry about adding its own BEC or adding a separate BEC to it like a Pololu circuit. It says it'll connect up to between 2 and 6S for the battery voltage, which gives us a lot of range on the flight controller. I'm going to be soldering this slightly different than some people may. First of all, I'm going to be using Sbus on the X4R FreeSky receiver, so therefore I won't need a ton of pins for things like PWM or PPM. Instead I'll just have 3 wires going to and from my FreeSky receiver. I'm also not using the KISS ESCs, therefore there's not built-in telemetry, and I won't have to use the transmission pad for each ESC. I will only need to use the ground and the signal pad for each ESC. Now there's a few cool things about this flight controller that I'm glad people are starting to do. First of all, you shouldn't have to put a Pololu circuit on every single flight controller or every single power distribution board just to power your stuff. And that's one thing that I appreciate about the KISS flight controller. The 2 pads right here, or pinholes, are for the voltage in connection. You can connect up between 2 and 6S LiPo batteries into those. And the BEC built into the board will regulate all that power for you, so you don't have to worry about that. Next, each one of these on this side, as we're facing here, we're going to be going ground, and then the signal wire for the first ESC. Then we'll do ground again, and then this will be ESC 3. And then if you go on the other side, which we'll flip this around, if you go on this side, directly underneath you'll have the ground and then signal for the second ESC, and ground and signal for the fourth ESC. And this flight controller can handle a hexacopter, which is pretty cool. But I only fly quads, so there you go. So all the signal wires we put on this side. We have our signal wire up here for the Sbus, so I'll be using this one, and then I'll be using the 5 volts going towards my free sky receiver here, and then the ground will be right here. Now all these other pins right here I won't have to use because they're all like AUX1 pads and pitch, and then on the other side you have your ground. Sorry, wrong side. On this side you have your pitch and your roll, your yaw, and the AUX2 that you need if you were doing something like PWM. So I'll only be using the opposite sides, these 3 wires right here, and I will direct solder those to it. Let's go ahead and solder up the pads on the flight controller. Alright, so this will be the PW1 ground. And then this will be the PWM1, or the signal wire 1. And then this will be the ground for signal 3, or motor 3. And this will be the signal for motor 3. Okay, made sure I did a good job on that. Yep, nice little solder balls, or solder bubbles, whatever you want to call them. So, alright. Okay, so we'll flip that back around, and we'll make sure that we're on the correct side, so it's the pads directly underneath the solder that we just laid. We're going to do on the other side and solder up those pins. And we're only going to need motor 2 and motor 4. So starting from the right, the back's going to be, this is the back right here, and so the back's going to be on the left on the underside, and then this one right here is going to be the ground for motor 2 right here, with the 2 dots on it next to the UARTs. Okay, and then as I said, I'm skipping the one in the middle because that is the telemetry wire for the KISS ESCs. So I'll be skipping that, and then we're going to do the motor 2 right there. And the next one over is going to be the ground for motor 4. So this one's ground for motor 4. And then this one is motor 4 for signal. Okay, so we have all the signal wires for each ESC and motor soldered already. We're going to flip back around to where the micro USB port is facing to the right, and we are going to solder the Sbus signal wires. Now remember, if you're not using Sbus, you're going to be using all these on both the top and on the, well, almost all of those on the top and the bottom. And that's if you're using PWM. CPPM, or PPM as it's commonly called, is a little different. You only need, I think, 4 wires if I'm not mistaken. So, alright, so here we have the Sbus signal wire right here. Then we need a 5 volt, and then the next one over is the ground for that. Alright, we've already soldered the signal inputs and ground inputs for each ESC, both on the front and on the back side. We've also soldered the pads for the Sbus connections to the X4R receiver. Next, we're going to solder the pads for the RX and TX, which go to your MicroMinim or other OSD. It's pretty easy. You just solder these two pads, and then you're also going to want to solder this pad right here, the ground pad. The 5-volt and the top ground pad are the pads for your buzzer, but this ground pad is going to be for your OSD. You may have also noticed that I've also soldered pins right here going to the voltage in, positive and ground connections. I'm going to be using a JST connector that's attached to the power distribution board on my Alien to directly connect that to the power. Now that I have everything, all the pads soldered up correctly, and don't forget to remove the boot jumper pad if you've updated your firmware on the flight controller. Don't forget to unjump that. Once you have all those pads soldered up, then it's time to just solder your ESCs to them. I've actually decided that I am going to cut these wires short and solder them directly to the cable. This is a really long wire. Not sure if you can see it, but these are really long ESC wires. So cutting them is going to lengthen the time that it takes to communicate, even if it's only by a nanosecond. And it's also going to make for a much cleaner build. So that's why I'm going to do that. I'll go ahead and show you how to do the very first one. Now mind you, the KISS flight controller operates in the reverse order as your standard flight controllers. So generally like in beta flight and clean flight, this motor right here, the bottom right hand motor, is going to be your motor 1. With the KISS F flight controller, the top left motor is going to be your motor 1. So this will be PWM1, this will be PWM2, and then this will be PWM3, and this will be PWM4. So solder these accordingly on your flight controller. First we'll start off with soldering PWM1, which is very easy to see. Right. If you remember, this is the PWM1. So we're going to go ahead and cut these wires. I'm going to be running this wire underneath my flight controller. Cut it a little longer than I need it, so that way I have room to work with, although that's not really that much room. Cut it a little too short. Then you go ahead and strip these. Sorry about trying to get everything in shot. I'm kind of holding this camera in my lap as I don't have a good tripod yet that actually fits on my desk. Okay, strip that first signal wire. Yellow is signal, black is ground. Kind of obvious, but make sure you've got the right ones going to the right places, because you do not want to reverse those. Alright, so once I have those stripped, I'm going to go ahead and tin them up. I generally always pre-tin my wires. Make sure this wires are all together. Okay. I'm going to use a set of tweezers. I'm going to connect the ground, which is over here on the left side. And solder it to that pad. Next we're going to be doing the signal wire, which, remember, I'm not using the KISS ESCs, so we'll be soldering that. We'll be skipping that one in the middle. And of course it's not going to want to stay. Okay, so there we have it. You can see that first two signal wires are soldered up. I'll bring you back when I've finished the rest. Okay, so I promised I'd bring you back after I finished soldering the ESCs to the flight controller, and I've already done that. As you can see, here are all the ESC wires. I really like being able to solder it directly, as it does keep things way more concise, and I like how they laid out the pads for this flight controller. They're all easy to access, they're all right there together, so you don't have to go all over the place, and it's not hard to get the wires there. Sometimes you can have some issues with that. The Sbus signal is up here, and those have been wired as well, and they have been connected via servo to my X4R, which I have heat shrinked. The power cable I have right here connects directly to these pins on top of the flight controller. I could have done a better job with that, but it definitely works, and it's a solid connection right there, so I don't have to worry about it losing power. Now it's time to go ahead and set your flight controller up if you haven't already done so. Okay, so now it's time to flash firmware on your KISS FC. You don't have to upgrade to the beta, but I'm going to. The beta allows you to run smart port telemetry with your FreeSky receivers, and allows you to do a few other things with the other receivers as well. So I'm going to go ahead and update to the newest firmware. So the first thing you want to do is you want to go to flyduino.net, and you're going to scroll down to the KISS 32-bit FC. Then you'll scroll down once you've clicked on that, and you'll want to do a couple things. First of all, you want to get the Chrome app GUI. You can also do that from the Chrome store. Just type in KISS FC. You're going to want to download the firmware update, which is right here. We'll click on that, and you'll click right here on KISS FC V102 update download, and that'll download that file. If you want to read the instructions, this is a great set of instructions that you can read. It details the entire process, and it's pretty simple. So you can click on that. I'm going to go ahead and unzip the file. Once you've downloaded that firmware, you're also going to want to download Diffuse. You can scroll down and click on the Diffuse download. You'll scroll all the way down to the bottom and you'll download it. And then you'll want to unzip it, and it'll take a few minutes to download. Once you've downloaded the Diffuse, you're going to open it up and unzip it to somewhere where you need it. I already have it unzipped on my computer. So it'll eventually open up to you, but if you don't have it opening up automatically, you can just type in here and type Diffuse demo,
and this is the desktop app that you want. So you'll go ahead and open that up, and you can follow the instructions right here, and it will tell you what to do. So now it's time to connect your flight controller to the actual board. I have had problems connecting it to a USB 3.0 port, so you may want to connect it to a USB 2.0 port just to be safe. And remember, you have to solder your boot jumper pads before you go to this step.
Once you've downloaded the necessary items to flash your KISS flight controller, you're going to want to solder your boot jumper pads on the flight controller. This puts the flight controller into bootloader mode that allows you to connect to it via the USB and actually flash it. Here we have the boot jumper pads right here. And all you have to do is put a little solder blob on one of them and then bring it over to the other one so that they're connected. I'll go ahead and show you how to do that now. Okay, so as you can see, that has been soldered. And the blob of solder is on both pads. So now you can connect your flight controller to your computer and it be in bootloader mode.
Okay, so you may see that it's installing a device for the first time that you connect your KISS flight controller. So go ahead and leave that up and running and wait for it to finish. Once it's finished installing that, what you're going to do is you're going to choose a file, and you want to go to wherever you have it stored in, and it will automatically look for a .dfu file. You're going to click on the KISS FC v1.02 beta DFU file, and you will open it, and it will tell you that the file has correctly been loaded. Next, you will hit upgrade, and you got to make sure that the STM device in DFU mode has been selected here in available DFU devices. You're going to want to click yes to removing the read protection, and you're going to want to continue or click yes to continue. Then it'll show the target being downloaded and everything being upgraded. Once it says upgrade successful, if you want to make sure or double check to make sure, you can always click verify. Click yes, and it will verify that the target was flashed successfully. There have been a few issues with DFUs identifying your STM device in DFU mode. This can be for several reasons, but it explains what you need to do here in this case. I had this exact same issue on the very first KISS flight controller that I was flashing. Now, what you have to do is you have to go to Device Manager, bring it up. You'll want to go to View and Show Hidden Devices. There should be a tab underneath Universal Serial Bus Controls, and I'm not sure why it's not showing up on my laptop right now. But what you'll have to do is there's a tab that's going to be called USB Devices. So not USB controllers, but USB devices is what you're going to be looking for. And you want to go down to the bottom option in that tab when you've opened it up and right click uninstall, and then it should ask you delete associated files, and you'll want to click yes. Then you'll unplug your KISS flight controller and plug it back in, wait for it to install, and if it still doesn't detect it, uninstall every single one of them until it does. Even if you know that one goes to the KISS flight controller, uninstall it, delete the files, and let it reinstall itself again. Eventually you'll get it to work. It took me several tries. One other thing is if you have a ZADIG file on your computer, the actual program file itself, you'll want to delete it and remove it from your computer, as that could interfere with defuse and DFU mode. You can click quit, and then you can remove your USB device that's attached to your KISS flight controller, and you have it flashed now. The next thing to do is to unsolder your boot jumper pads.
Simply remove the solder from the KISS flight controller to the point where the pads are not bridged any longer. It's fairly easy to do. Essentially, all you got to do is just wipe it away. There you go. Both pads do have solder on them, but they are no longer bridged together, and that's what you need. So you're done with that, and now you can safely connect your flight controller to the computer and to the GUI, and now you can configure everything that you need to configure as far as flight characteristics are concerned.
So once you have it flashed and your pads desoldered or debridged, you can go to your Chrome app launcher and then you go to the KISS FC GUI and open it up. This is what it looks like, and here you have some valuable information for where all your pins are at and what they are. Very handy. You always should really know what pinouts you're going through. It's easy to look at a video, but it's always the best idea to have this up as a reference when you're doing your own soldering. But now you can plug your flight controller up. And you can connect it. Now mind you, mine is not currently on my actual quad, but here you can set up quite a few different things. You can set your min throttle, your max throttle, whether or not you have one shot 125 or one shot 402, or if you're running in 3D mode, or if your flight controller is backwards, though I do wish they had it to where you could set it up at your own angle, but you know, that's alright. Here you have your PID settings. You can do presets or customs. Currently I'm running on Mr. Steele's 5-inch alien. That's the ones that I chose. But I have some other things that I want to change with it. You always want to tune your own quad to how you fly, and to its own setup. So my setup is different than his. It's not the exact same. I don't run the same motors, I don't run the same ESCs, but I picked his because I figured it would get me closest to where I needed to be, and so it would take a lot of the tuning process out, which means more flying time for me. Here you have your advanced options. You can, set up your throttle pit attenuation here, set it up how you want it at full throttle, mid throttle, and so on. And then you can also do your PID voltage correction, which sets that up to where when your battery is lower in voltage or higher in voltage, how your PIDs handle there. And then you always want to save your settings. Here you can run your auxiliaries for ARM or level mode or 3D mode, or your buzzer. I just run ARM. And this is a very important diagram too, because you want to make sure that you have your ESCs wired up correctly. And in clean flight and beta flight, your PWM1 is actually here in the bottom right, and then it goes PWM1, PWM2, PWM3, and PWM4. In the KISS flight controller, it's very different. Though the motors are spinning the same direction, the order in which you wire them up is very important. So you need to make sure that you have looked at this and keep this fresh in your mind when you're soldering, to make sure that you're soldering the ESCs to the correct places. You can also go to your data output tab, and you can make sure that your KISS flight controller is receiving input in the receiver from your transmitter, whatever one it might be. Very important to check, and you can calibrate your accelerometer here, and you can make sure your motors spin up as well. Pretty simple GUI. Actually, it's the most simple GUI I've had to deal with, and I actually like that. Beta flight definitely has a few more tabs than it probably should, though I do like being able to play with everything, but I mean, there's stuff that I just don't even look at there. There's only like 5 tabs that I actually look at. So, do like this setup. I need to set my rates higher in Mr. Steele's. Yeah, I need to set my rates higher. My rates are freaking crap because it doesn't change your it doesn't change your rates. It only changes your PIDs when you upload a PID profile. So make sure to change your rates. I was trying, but that should be pretty close to what I want. So anyway, you can go ahead and do that. And save your settings when you're done. And it's a very simple GUI. It does everything you need it to do. Nothing more, nothing less. You can disconnect, and if you already have your KISS flight controller set soldered up, then you can go out for a fly.
So here we have it all finished. It's all put back together. I just tested it and flew it just around my room and here, but they all spin up nice and evenly, and I can already tell a difference in the throttle responsiveness and just the way that it flies and handles. Just even in my room, it feels very smooth compared to honestly a lot of the beta flight stuff that I've flown, and the clean flight stuff. That's pretty much all I've been flying since 1.4 or 5. Beta flight, I've been flying that for a long time, and I liked clean flight. It was a lot better than base flight, but this KISS flight controller is definitely on another level in my opinion, just from what I've seen, and from what I've seen in videos, and then how it feels just at hover and flying around in this tiny room. So I'm pretty excited to get this out in the field and try it out. So I'll upload a video of my first flight on the KISS flight controller to my channel, but that probably won't be for a few weeks, as the weather is supposed to be crap for the next few weeks. Appreciate y'all checking in and tuning in, and have a fun flight and safe flying, and enjoy the KISS flight controller if you get it. Catch y'all in the next video.